Okay, let's look at number 35 now, which is now moving into 8-4. We want to find the perimeter of this polygon, okay? So there's my answer. We're going to figure out how we got that. So if this whole thing here is 20.1, that's important. We'll come back to that, though. What we really need to focus on is the theorem that applies to two tangents. So when two tangents meet outside here like this, then my theorem, I think it was theorem 2 in 8-4, says that this piece is congruent to this piece here. So that is also going to be 13 right here. Okay. Well, then I'm going to look at this right here. So this piece is just the rest of it. I know the whole thing is 20.1. So I want to subtract 13, just 13, right? So that's going to be 7.1. So that's the remaining piece here, which is also the same as this piece right here because of my theorem that I just told you about. Make sense? We also know that 10.6, which is here, is the same as this piece here. So that's also, oops, come on, 10.6. And then lastly, this is 8.2, then this is 8.2. So to get the perimeter of that entire quadrilateral or polygon, you're just going to add them all up. So 13 plus 7.1 plus 7.1 plus 10.6 plus 10.6 plus 8.2 plus 8.2 plus another 13 should give you 77.8. And that's it. Cool. Let's do 37 while we're here. 37. Theorem 1 from 8-4 says that this radius is perpendicular to this tangent. Ta-da! Guess what that means? We have a right triangle, which means I can do Pythagorean theorem. Make sure you know the hypotenuse is always across from the 90-degree angle. So that would become 9 squared plus, we don't know, so let's call it x squared, equals 15 squared. That becomes 81 plus x squared equals 225. From there we subtract 81 from both sides of the equation to get 144 equals x squared. So lastly, you square root both sides and x is equal to, ta-da, 12. For a lot of the 8-4 questions, you're going to be doing Pythagorean theorem. Just so you know. All right, great. And let's pause.